Good morning to all of you. Today, this video is going to be my third video on the chapter Polynomials. Now, today in this video, we are going to learn the next and new topic, that is the relation between the zeros and the coefficients of a polynomial. In fact, here we shall be finding such relation only for quadratic polynomials, not for all polynomials, only for quadratic polynomials. That means I am trying to say we shall find the relation between the zeros and coefficients only for quadratic polynomials, because in our class 10 syllabus only we deal with quadratic polynomials or quadratic equations. That's why here we shall only find such relations only for quadratic equations. So please students, keep in mind, we have to be very clear about that before starting the topic. Understood? Now let us know what is the such relations for the quadratic polynomial. Now let us take the general form of the quadratic polynomial, that is p of x equal to x square plus bx plus c. We know it is the general form of the quadratic polynomial where a, b, c all are real numbers and a not to be 0, and at the same time we need to remember a is the coefficient of x square, b is the coefficient of x, and c is the constant part. That means here a, b, c all are coefficients, right? Since here it is a quadratic polynomial, so we can say it will have maximum 2 zeros. So it will have maximum 2 zeros because it is the quadratic polynomial, and they are alpha and beta. That means alpha beta are the 2 zeros of the quadratic polynomial. Now we have to know the relations between the zeros alpha and beta and the coefficients a, b, c. Now we shall have two relations between the zeros alpha beta and the coefficients a, b, c. What are they? Now let us know them one by one. The first one is alpha plus beta equal to minus b by a. Alpha plus beta means sum of two zeros will be equal to minus b by a, where b is the coefficient of x and a is the coefficient of x square. So you can remember as sum of the two zeros will be equal to minus coefficient of x by coefficient of x square. Or also you can say alpha plus beta equal to minus b by a. That is the first one. The another one is alpha into beta equal to c by a. Alpha into beta means product of two zeros will be equal to c by a, where c is the constant part and a is the coefficient of x square. So if you want, you can remember as the product of two zeros will be equal to constant part by coefficient of x square. Also if you want, you can say alpha into beta equal to c by a. So in this way, total we shall have two relations between the zeros and the coefficients. The first one is alpha plus beta equal to minus b by a, and alpha into beta equal to c by a. So by any means we have to remember these two relations. It is very very important to remember, because in every year in CBSE board exam question comes from here. So please don't ignore it. Understood? How to apply them in the problems, it will be understood properly if you work out some questions. If you work out some questions, it will be understood how to apply these relations. Understood or not? Now let us solve some questions from the exercise 2.2, right? One by one. Now let us come to the exercise 2.2. Now in this video we shall be solving three questions from the exercise, and these are question number 1 ka Roman 1, Roman 5 and Roman 6. But before that, first let us read the question. What is told here? Find the zeros of the following quadratic polynomials and verify the relations between the zeros and the coefficients. That means first we have to find the zeros of the given quadratic polynomials, and after that we have to verify the relation between the zeros and coefficients. That is the main work to be done here. Now let us solve one by one. Let's come to the question number 1 ka Roman 1. Here a quadratic polynomial is given, that is x square minus 2x minus 8. Now here we have to find the zeros of this quadratic polynomial, and after that we have to verify the relation between the zeros and coefficients. That is the main work to be done. Understood? And at the same time, we have kept ready the general form of the quadratic, that is ax square plus bx plus c, where a not to be 0. And at the same time, we have kept ready the required relations. What are they? Alpha plus beta equal to minus b by a, and alpha into beta equal to c by a. That we have learnt just right now. Understood or not? Now, first we need to modify to find out the coefficients a, b, c. For this purpose, it can be modified as 1 into x square, and minus 2x can be written as plus minus 2 into x, correct? And this minus 8 can be written as plus minus 8. Now, comparing these modifications with the general form of the quadratic. Now, if we compare this modification with the general form, then we can say a equal to 1, b equal to minus 2, correct? b equal to minus 2, and c equal to minus 8. Understood or not? Now we have to keep ready because it will be used later on. So in this way, we have found the coefficients. A equal to 1, b equal to minus 2, c equal to minus 8. On comparing these modifications with the general form. Correct? Now after that, the next step is we have to find the zeros of this polynomial. And how to find the zeros of the polynomial we have seen in the previous video. Right? So again I am reminding you, to find the zeros of a quadratic polynomial, any other polynomial, first we need to make it 0. We have to set the quadratic polynomial equal to 0. That is the first thing to be done in the purpose of finding zeros. Understood or not? Now therefore it becomes an equation. Now we have to solve for this equation. Means we have to find the values of x. Here how to solve? By using middle term factor. Means by breaking middle term. Now look at here. How to do the middle term factor in the left hand side. Here the coefficient of x square is 1. And the constant part is 8. Now multiplying this 1 to 8. Correct? It is the simple rules of middle term factor, we know. So if we multiply 1 and 8, it becomes 8. Now we have to split 8 in such a way that we shall be getting minus 2 in the middle. Right? So for this purpose, this 8 can be factorized as 1 and 8, 1 into 8, or 2 into 4. Understood? Here if we take 1 and 8, we can never bring minus 2 by using them. Again I am saying, if we take 1 and 8, we can never bring minus 2 in the middle by using them. That's why we cannot take this possibility. So it is cancelled. But if we take 2 and 4, by using them we can bring minus 2 in the middle. That's why we have to go for these two factors. Okay, let us see here. Let us see how to bring minus 2 by using 2 and 4. Now write down x square as it is. This minus 2x can be written as minus 4x plus 2x minus 8 equal to 0 as it is. Understood? Though we have used this 2 and 4 here to bring the minus 2. So my job is done. Already the middle term is broken in this way. Now taking x common from the first two, it becomes x into x minus 4. Correct? Similarly, taking 2 common from the last two to bring the same factor equal to 0 as it is. Now here, see here, we have got the same factors, x minus 4. Means we are going in the correct way. We are happy. But if somehow if you get the different factors, means we have done something wrong in the previous step. We have to recheck. But here we got the same factors. Means we are going the correct way. We are happy. Now taking x minus 4 common from the whole. Then it becomes x minus 4 into x plus 2 equal to 0. Correct? In this way, we have got two linear factors in the left hand side. And it is multiplied and equal to 0. So we can claim either first factor is 0 or second factor is 0. Now from the first factor we get x equal to 4 by taking 4 on the right hand side. Correct? And here similarly we get x equal to minus 2 by taking this one on the right hand side. X equal to minus 2. So in this way we have got two values of x, 4 and minus 2. Correct? These are the required zeros of the given quadratic polynomial. These are the required zeros for the given quadratic polynomial. Understood or not? So likho. So these are the required zeros of given quadratic polynomial, QP, quadratic polynomial. So already we have found the zeros of the given quadratic polynomial. Now let us give the name as, मान लो it is alpha, it is beta, right? Let the first zero is alpha, the second zero is beta. So you can say here alpha equal to 4 and beta equal to minus 2. So my first step has been done. Now let us come to the second step. Second step means second part. Now we need to verify the given relations. Understood or not? Now let us verify. First find the sum of zeros. Means find first alpha plus beta. Correct? Here alpha is 4 and beta is minus 2. It becomes 2. 4 minus 2, 2. At the same time, on the right hand side, keep ready the value minus b by a. Now look at here. What was the value of b in the previous step? Minus 2 and a is 1. Now put it here. Minus b as well. Minus 2 here and 1 here. Minus 1 is plus, it will become 2. So here we got alpha plus beta equal to 2. Also here minus b by equal to 2. Now if we compare, then we see both are equal. So you can say from here alpha plus beta equal to minus b by a. The first relation has been verified. So you have to write down verified. If they are not equal, then you have to write not verified. But here both are equal, so you have to write down it is verified. So my first relation has been satisfied. Now let us come to the second relation. Similarly, find the product of two zeros. Means you have to find alpha into beta. Alpha was 4 and beta was minus 2. 4 into minus 2, it will become minus 8. Correct? Similarly, on the right hand side, keep ready c by a. Now look at here. What is the value of c? The c was minus 8. Correct? Now put it here. And a was 1. Now it becomes minus 8. Now compare alpha into beta and c by a. If you compare, we see both are equal. So you can say here alpha into beta equal to c by a. Both are equal. Both are equal to 8. Correct? Both are equal. Both are equal. And both are equal to 8. Sorry, minus 8. But they are equal. Also the second one is verified. Also the second relation has been verified. So in this way, you have to complete this math. And this type of math is very, very important for the board exams. because it comes, you can say, in every board exams, in every year it comes. So please don't avoid it, don't ignore it. Again, I'm saying from the first because it is very, very important for the board exam. First, you have to modify to compare with the general form to find out the value of ABC. ABC are the coefficients. After that, you have to find the zeros. And you know how to find the zeros. First, you have to take it is equal to 0. First, you have to set the quadratic polynomial equal to 0. Then, you have to solve for x. Somehow, you have to find the values of x. After solving x, we are getting some values of x. These will be the required zeros. After finding zeros, give the name. Give the name as alpha beta. Then satisfying, then checking the both relations one by one. First find alpha plus beta on the right hand side at the same time, then find minus b by a. Then compare. If you see both are equal, then it is verified, otherwise not. Similarly, then find alpha into beta, and at the same time find c by a on the right hand side. Then compare. If you see both are equal, then it is verified, otherwise not. In this way, you have to verify the given relations. Understood or not? So in this way, the first question has been solved. Come to the next question to be solved. 1 Roman 5. Similarly here, we have to find the zeros of this polynomial. After that, we have to verify the given relation. Understood? Now here we see it's all about t. That's why you can say it is a polynomial of t. Correct? Now first you have to find out the coefficients a, b, c on comparing with the general form. So for this purpose, we need to modify this polynomial. This one can be written as 1 into t square, but here no t is there, so it can be written as plus 0 into t, and minus 15 can be written as plus minus 15. Correct? Now compare these modifications with the general form. Then we get a equal to 1. Correct? A equal to 1. B will be 0 because there is no t, so B will be 0. And finally C will be minus 15. Understood or not? So A equal to 1, B equal to 0, C equal to minus 15. In this way, we have kept ready all the coefficients because it will be used later on. Now in the next step, we have to find the zero of this polynomial. For this purpose, let us take this polynomial to be 0. Understood? Now, this t square can be written as t whole square. Correct? And this 15 can be written as root over 15 whole square. Correct? Equal to 0 as it is. Now we are getting the formula of a square minus b square. We know the formula of a square minus b square is a plus b into a minus b. Correct? So here it is a, it is b. Now simply using the formula of a square minus b square. Now it becomes t plus root over 15 a plus b into t minus root over 15 equal to 0 as it is. Means a plus b into a minus b. Now in this way we have factorized. In this way we have got two linear factors in the left hand side and it is multiplied equal to 0. So we can say either first factor is 0 or second factor is 0. Okay. Now from here we can say t equal to minus root over 15. Let us take this one on the right hand side. Similarly here we get t equal to root over 15. Similarly taking this one on the right hand side. So in this way we have got the two values of t, plus root over 15 and minus root over 15. These are nothing but the required zeros of given quadratic polynomial. देखो, so these are the required zeros of given quadratic polynomial. QP means quadratic polynomials. So in this way, first we have found the zeros of the polynomial. Now let us give the name as before, like alpha and beta. Means we can say alpha equal to root over 15 and beta equal to minus root over 15. Correct? Now, so my first part has been done. Let us come to the second part. In the second part, we have to verify the given relations. Understood? First find sum of zeros. Sum of two zeros. Means alpha plus beta. Here alpha is root over 15 and beta is minus root 15. So both will be cancelled, plus minus 0. Correct? At the same time, keep ready b minus a. Now keep ready minus b minus a. Now look at here. What is the value of b here? 0. So put it here. Minus 0 as usual. 0 by, and a was 1. 0 by something, always 0. Because the numerator is 0, always it will be 0. So already you have got alpha plus beta equal to 0. Also you have found minus b by a equal to 0. Now compare. No? If you compare, then you see both are equal. Both are same. So you can say alpha plus beta equal to minus b by a. That means the first relation has been verified. So likho, it is verified. Understood or not? Now let us verify the second one. Similarly, find the product of two zeros. Product of two zeros means you have to find alpha into beta. Here alpha was root over 15 and beta was minus root 15. Correct? Then it will be minus into plus, minus root 15 into root 15. Root 15 into root 15. It will be, then the square root will be removed, minus 15. Correct? So in this way, we have got alpha into beta. At the same time, just find out c by a. Now, look at here. What was the value of c here? Minus 15. And a was 1. Now put it here. Minus 15 by 1 means minus 15. So put it here. C equal to minus 15 and equal to 1, minus 15. So now compare alpha into beta and c by a. If you compare, then you see both are same. Both are equal to minus 15. So you can say alpha into beta equal to c by a also. Also it is verified. Understood? So the question has been finished here. First we have found the roots, root of 15 and minus root over 15. After that we have verified the functions. Okay. Come to the question number 1016. Similarly, here one quadratic polynomial is given, and here also in the similar manner we have to find the zeros first. After that we need to verify the given relations. Understood? First let us find the value of ABC on comparing with the general form. So for this purpose we need to modify. Now this 3x square can be written as 3 into x square as it is. This minus x can be written as plus minus 1 into x, and this minus 4 can be written as plus minus 4. Correct? Now compare these modifications with the general form. Then we get a equal to 3, a equal to 3, b will be minus 1, b will be minus 1, and c will be minus 4. So in this way we have got the coefficients a, b, c. Now we have to used in the next steps. So please keep ready it. Now in the second step, we have to find the zeros of this quadratic polynomial. Similarly, let us take first 3x square minus x minus 4 to be 0. First we have to set equal to 0. Then it becomes an equation. Then you have to solve for x. Means we have to find the values of x ultimately by doing Milton factor. Here the coefficient of x square is 3. And here it is the constant part 4. Now multiplying 3 and 4, it becomes 12. Now we have to split 12 in such a way that we shall be getting minus 1 in the middle. Correct? Now this 12 can be factorized as 1 into 12, 6 into 2 and 3 into 4. Now we have got 3 possibilities for the factors. If we go for 1 and 12, we can never bring minus 1 in the middle by using 1 and 12. That's why it is cancelled. Similarly, if we take 2 and 6, also we can never bring minus 1 in the middle by using 2 and 6. Also it is cancelled. But if we take 3 and 4, by using them we can bring minus 1 in the middle. So we will go for these factors. Correct? That is the rules of Milton factor. Already we know it. Now 3x square will be as it is. This minus x can be written as plus 3x minus 4x. Correct? Now see here, we have used this 4 and 3 here to bring minus 1 in the middle. So minus 4 will be as it is, equal to 0. Now taking 3x common from the first two, it will be 3x into x plus 1. Taking minus 4 common from the last two to bring the same factor. Though we have got same factors, we are happy. Means we are going in the correct way. Equal to 0 as it is. Now it is a common factor from the whole. So taking x plus 1 common from the whole. So it becomes x plus 1 into 3x minus 4 equal to 0. Correct? So in this way we have got two linear factors in the left hand side and both are multiplied and equal to 0. So in the similar manner we can say either first term is 0 or second factor is 0. Either first factor is 0 or second factor is 0. Now from here we get x equal to minus 1 by taking 1 on the right hand side. Similarly here we get 3x equal to 4 by taking this one on the right hand side. And we get here finally x equal to 4 by 3. Correct? So firstly we got x equal to minus 1 and secondly we got 4 by 3. So ultimately we have got two values of x. These are the required zeros of the given quadratic polynomial. So likho, these are the required zeros of the given QP polynomial. Quadratic polynomial QP. So in this way we have got two zeros of the given quadratic polynomial. Now let us give the name as alpha and beta like previous maths. So we can say alpha equal to minus 1, the first 0, and beta is the second 0, that is 4 by 3. 4 by 3, correct? So here we have found the zeros. My first part has been completed. Now let us come to the second part. Second part means we need to verify the given relations. That is the second part. Now first, like before, find the sum of the two zeros. Alpha plus beta. What is the value of alpha here? Minus 1 plus 4 by 3. then it will be, if you do the adding, then the LCM will be 3. So minus 3 plus 4 means it will be 1 by 3. So here the value of alpha plus beta is 1 by 3. At the same time, find out minus b by a. Now look at the previous step. What was the value of b here? Minus 1. And a was 3. So keep minus as it is. B was minus 1 and a was 3. Minus minus plus, it will become 1 by 3. Correct? Now if we compare alpha plus beta and minus b by a, we see both are equal, both are same, and both are same to 1 by 3. So we can claim alpha plus beta equal to minus b by a, and both are equal to 1 by 3. That means the first relation has been satisfied, means verified. Understood? So my first relation has been satisfied. Now let us come to the second relation to check. Now first find product of two zeros, means alpha into beta. Now what is the alpha here? Minus 1, and beta was 1 by 3. Then it will be minus 1 by 3. Correct? At the same time, on the right hand side, find out c by a. Now look at here. What was the value of c here? Minus 4, and a was 3. Now put down here. C was minus 4 and a was 3. So it will become minus 4 by 3, means minus 4 by 3. Sorry, it was 4 by 3. So alpha into beta was minus 4 by 3. Correct? Here alpha was minus 1 and beta was 4 by 3. So alpha into beta will be minus 4 by 3. And here we see c by a equal to minus 4 by 3. Now compare them. If we compare, we see that both are equal. So we can say alpha into beta equal to c by a. Also it is satisfied. Also the second relation has been verified. Understood? That is the complete math. In this way we have to solve all the maths in these types. Understood? Today I stop here. In the next video we shall be solving the remaining maths of the exercise 2.2. So for these days, please be safe, be healthy and stay at home. Thank you very much.